Okay, so on this question, a study was done to look at the relationship between the number of vacation days employees take each year and the number of sick days they take each year. The results are shown below. So we have, these employees, how many vacation days, like this first employee took 9 vacation days and 6 sick days. Second employee took 1 vacation day and 5 sick days, etc. These are each a different employee and how many vacation days and sick days they took. Find the p-value for the linear correlation. The significance level is 0.05. Interpret the meaning of the y-intercept. Interpret the meaning of the y-intercept. Okay, so really, this is what they're actually asking us. Interpret the meaning of the y-intercept. So what is the y-intercept? What's that? Well, let me go with you to the notes. And what are we talking about here? They're talking about linear correlation notes. So I'm going to go to the notes and get the information on linear correlation. Let me show you. Let me grab it from the notes. I think is it right? No, not that one. Maybe I'll have to. Yeah, there it is. All right. This is the notes here. So here's the exam 4 notes. And here's linear correlation number 6, right? What does it say down here? The equation is y equals a plus bx. The slope is the b. The y-intercept is the a. Oh, okay, let's write that out. I'll bring that back up here. So it's y equals a plus bx. And this is what they mean by the y-intercept, which is what they're referring to, y-intercept. See how I got that? Right from the notes, right down here. A, the number right there in the front, is the y-intercept, the part that's not next to x, right? With the b is next to x, but the a is not. That's the y-intercept, okay? So that's the y-intercept. So what does that mean? Well, the meaning of a y-intercept, we had some of these in the homework, is a little tricky. It's what you'll get. Actually, so that's so we need to do this problem now. So we need to put this in our calculator. So yes, let me go back here. We need to find out what it is even on this one. So let's do it. So first off, put the data in L1 and L2, then do a linear regression t-test. Probably should have done that first, whatever, it doesn't matter. So this is going to be L1, L2. Put those in your calculator. I'm going to do it right now. So L1 and L2. All right, and then so L1, L2 in your calculator, and then go to stat. So here, then go to stat. Test, go down. I think it's F, isn't it? Yeah, F, which is linear regression t-test. Okay, and then when you do, you get the following, it'll say X list, that's L1, Y list L2, frequency 1, P and P, and it'll have not equal to 0, less than 0, greater than 0, and then calculate. Okay. And so there's what we're going to put in our calculator now. So make sure you're seeing this in the notes. So we're testing. See, I saw the word linear correlation in the beginning of the problem, right? They talked about that. Right here, linear correlation. So then I went to the notes and went, okay, testing linear correlation. Put data in L1, L2, go to linear regression t-test, choose that stuff, okay? And so when you do all that now, whenever you're doing linear regression t-test, you're going to choose this not equal to 0. I'm going to choose that not equal to 0 there, and then calculate. And so when you do, what do you get? I'm getting, so here's what comes out on my calculator screen. What comes out is a p-value of 0.0620. Let me write it over here. Getting a p-value of 0.0620. Now, what do we always do with our p-value? We have to compare it to the alpha level, huh? So what's the alpha level, right? Like usual, it's 0.05. 0.05 in the alpha level down here. And how does the p-value compare? Well, the p-value is greater, right? If you're not sure, line them up, 0.0620. You can always add zeros to the back of the, if you're having any trouble comparing digits, just line up the decimals and fill in zeros for anything missing. It's really clear to see that the 620 is bigger than 500. So the p-value is greater. Now, what does that mean? Well, it actually tells you, we don't even have to think about it. It tells you right here. If the p-value is less, well, that's not our case. If the p-value is greater, then there is insufficient evidence, too weak, to allow us to use the linear regression equation. It is invalid to use it. It goes on and says more about that, but basically it's invalid. You cannot use. It's too weak to allow us to use it. It's invalid to use. You cannot use it. What that means is there's not strong evidence that the data is linear, right? You know what I mean? Like if I was to graph this on these dots on a line, like over 9, up 6, there'd be a dot, and over 1, up 5, there'd be a dot, et cetera, et cetera. You would find that these dots are just spread out too differently. They don't really line up. There's not strong evidence that these points, these are XY points, right? You could graph. We did that in the homework, right? These XY points, I'm not seeing the graph. We could make the graph. We don't want to take time to do that. The calculator is telling us, when it tells us the p-value is greater, it's saying, hey, the p-value is greater, meaning there's not strong evidence, right? There's not, that's what it says down here for us. P-value is greater. There is insufficient, not strong. It's too weak to allow us to use the equation. So that equation, this equation we just got, it doesn't fit. There is a line equation, but the dots don't fit the line equation very well at all. They don't fit it very well at all, right? The calculator can always calculate for you a line fitting through the middle of the dots, but look, those dots are not very tight to that line. Nobody would look at these dots and say, hey, look, they all line up, right? So it's invalid. It's baloney to use that equation. That's always how technology works in the real world. We have to be a wise consumer of technical information, meaning calculators and computers will give us answers, but we have to be the wise one to know when the answers are valid or when they're not really valid. And in this case, the dots are crazy. So yes, the calculator will find the line that goes through the middle, but we shouldn't use that equation because the dots are everywhere. How do we know? Because the p-value came out greater than the significance level, greater than 0.05. And that tells us right here, if the p-value is greater, then there's insufficient, there's weak evidence, too weak to allow us to use the equation. It's invalid to use it. The dots are not very tight, so it's invalid. So where's that option then? Because the p-value was greater than the significance level, the use of the regression line is not valid. There it is. There's our option, so we don't do any more. It's not valid. Now, if the p-value was less, and sometimes you can get problems where the p-value is less. If the p-value was less, then we had some of those. Let me just show you in case, and on an exam you take, that it comes out less. If it was less, if it was like 0.04 and therefore less than the 0.05, if the p-value was less than the alpha, then I would have gone with, up here, it's less. It says it would have been less. Then there's strong evidence that they have a linear relationship. On a graph, the dots generally fit a line. So we can use the equation. So we would use it. So we would say, okay. And then the calculator would give us an equation. If you notice, it says y equals a plus bx right in your calculator, and it tells you the a, right? The a in my case was 3.99 on the one we just did, and the b was negative 0.306, or let's just go negative 0.31 x, like that. It gives you an a and a b, okay? And then so then you have an equation. And so then in that case, what would be the significance of, and remember, this is the y-intercept right here. Remember, the y-intercept was a. Be this number. That's what the notes say right here. The y-intercept is a, right? It's the number not next to x, okay? What would be the significance of that? Well, do you understand? This is what y equals when we plug in x equals 0. You see, if I was to plug in x equals 0 here for x, this part would drop out and y would just equal that number. That's what the y-intercept is. The y-intercept is what y equals when you plug in x0, because that just makes this part drop off and y just equals that. Well, so what? What does that tell me? Well, what is x and what is y? You got to remember, x is vacation days, y is sick days. So in other words, this would be, this is sick days and x is vacation days. What that would mean then is if a person has 0 vacation days, they're going to have 3.99 sick days. That's what the equation would tell us in this situation. Yeah, and that's about 4. 3.99 is about 4, isn't it? That would tell us that if a person who takes 0 vacation days on average, and that would mean in this data set, the employees at this company, for an employee that has 0 vacation days, right? X is 0. Then this part drops off. Y will just equal 3.99 or about 4 sick days. How did I make all those connections? Because it said in the beginning, remember the x, the first variable is always x, the second is always y. X is vacation, y is sick. Here's the equation. The y-intercept is the a. It's the number not next to x, 3.99. How do you get y to equal that? Well, you got to get the other part to drop out, meaning you got to plug in 0 for x. So that's what y-intercept always is. It's what y equals when x is 0. You see, if you plug in 0, this will go away. If x is any other number, like 1 or 2 or 3, well, then, y will be 3.99 minus 3.31 times that number. But if x is 0, this just drops out. Y just equals that number in the front. So when there's 0 vacation days, there's about 4 sick days. So as employees that take 0 vacation days on average usually take about 4 sick days. That's what it's telling you. That's what the y-intercept is telling you there, is for employees that take 0 vacation days, they take about 4 sick days. Now, that's not our answer. That would have been right here. The best prediction for an employee who doesn't take any vacation days, right, that's 0 vacation days, is that the employee will take 4 sick days. That would be the case if P had been less, but ours was not. Ours was not. I just want to make sure, though, that you're clear in case you get a problem on the exam where the p-value is less. Our p-value was 0.06, it was greater. So we went with not valid. That's what the notes say. When the p-value is greater, it's not valid. You can't use it. The dots don't really form a line. They're not lined up very well at all. But if the p-value had been less, that tells you there's strong evidence that the dots line up. And so go ahead and use the y-intercept, find out what it is and what its real life meaning is in that case. So our answer is invalid. But if you had a p-value less, then your answer would have been this one, because when x is 0, no vacation days, y equals 4 sick days. All right, there we go.